Okay, so now they're asking us to find for the time interval 0 to 3, what is the what is the greatest distance between the particle and the origin? So what you have to remember is the particle moves along a line, the origin is the center of the line. We could say there are different locations along the line. We could number those locations like 1, 2, 3, 4, etc. This way we would go -1, -2, etc. So the origin is also known as location 0. It is not necessarily time 0. So what is the greatest distance between the particle and the origin? So the idea is the particle moves. We know that at time 0 the particle is here. It doesn't mean the particle is sitting there. It just means that if you were watching the particle at time equal 1, you would either see the particle move past this location at time equals 0, or maybe the particle is actually sitting there at time equals 0. Don't really know. So the particle moves, however it moves, back and forth. And at some moment, the particle will be at its furthest spot from the origin. That could be the most negative spot or the most positive spot. Our job is to find what is that greatest distance, either most negative or most positive, from the origin. So when I read that idea of finding greatest distance, I think min-max theorem. So min-max theorem says, okay, first thing, what am I trying to maximize? Well, I'm trying to find when the position is either most positive or most negative. One of the two. Good news is the min-max theorem will find both. So I look at my notes here, golden notes. There's this big note on the second sheet of the golden notes. And this big note says, clear this off, it says finding absolute max. And in our case, we're finding the absolute max of x of t. So finding the absolute max of x of t. Let's put this on a new screen here. Let's copy this over. This, copy, new screen. Okay, so we're trying to find the absolute max of x of t in this case, the position of the particle. Requires eliminating candidates or performing the candidates test. That was number one. Number two, first remember that the absolute max or min of x of t is always located at a critical or end point of x of t. A critical point of x of t, so x of t is where x prime, but x prime is the same thing as velocity. Is equal to 0 or undefined. So that's the very first thing you should do, is focus on finding the times when the velocity is 0. So back to here. Move this out of the way. first thing I always want to write down when I'm doing the min-max theorem is, I'm trying to find when, let's get rid of these boxes, sorry. Okay, I'm trying to find when x of t is min or max. So I focus first on x prime, which is v. And I've got to find when v has values of 0. So I get to use my calculator. So here's my plot of v. Here's my plot of v. This is the time, these are the times, when v has a y-coordinate of 0. So I write those down. So those are the 2 times when v has a y-coordinate of 0. I found that using the 0 function in my calculator, where you do the left bound, and you do the right bound. So here's my left bound, here's my right bound, this is my left bound, this is my left and right bound now showing. I do the guess, and the calculator correctly identifies the 0, or the y-coordinate of the velocity, has a value of 0. Right there, 2.507. Make sure I store that value. So make sure I put that value in my calculator. Okay, back to the theorem. So once we have the candidates, we're going to do the shortcut method of this theorem. There's a long method. So we've done this. We have identified where, in our case, x prime is equal to 0. We have 3 candidates now. Our candidates are, we have 3 candidates. Our candidates are time equals 0, time equal 3, that's the beginning and the end point. And then also that time in the middle, 2.507. We're going to skip a lot of these steps because they're not applicable to this problem. In this problem, all we have to do now is find the position of the particle at these 3 times, and one of those times will be when the particle is actually most left, and one of those times of the origin, and one of those times will be when the particle is most right of the origin. So do that here. This is I know the position at time 0 is 1. At time 2.507, I do the integral of the velocity added to the position at 1 to find that position. Similar for time 3. Therefore, the greatest distance is when the particle is at a negative position. But it asks for the greatest distance, that would be a positive number. The way this one was scored is if you have the correct answer, you get 1 point there. And the other one they would be looking for are these integrals. Usually they give a point for this information. They did not